Last time we talked about how we have shortcuts to prove that triangles are congruent to each other. Today, we're going to be using congruent triangles to show that there are corresponding parts of those triangles that are congruent as well. So here's the main idea. If you can prove that two triangles are congruent, so by any of those shortcuts we talked about last time, side, 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 angle, 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 side, or hypotenuse leg, then you will know that their other corresponding parts must be congruent as well. The way that we shorten this phrase is CPCTC, which stands for corresponding parts of congruent triangles are congruent. Take a look at example 1. In the diagram below is FH congruent to JL. If you look directly at the diagram, there's no information told about FH and JL. However, we can first determine whether or not these triangles are congruent, and if they are, then by CPCTC, we can say that FH must also be congruent to JL. So step 1, you need to first determine if the triangles are congruent, and if they are, show a proof. So look at the information that's given to us. FG is congruent to JK, HG with LK, and the included angle, angle G and angle K, are congruent to each other as well. So by side angle side, we can show that we have a set of sides congruent, FG with JK, set of angles, angle G and angle K, and another set of sides, GH and KL. So, because of this, we can say that triangle FGH is congruent to triangle JKL. Now that we have that, for step 2, we have to state, well, if the triangles are congruent, then you can say yes by CPCTC that FH must be congruent to JL. If we weren't able to show that the triangles were congruent, then you would have to say that there's not enough information. In this case, the triangles are congruent, so we can say that FH is congruent to JL. Let's take a look at example 2. In the diagram below is angle D congruent to angle G. So again, first step, can we prove that the triangles are congruent? Well, it looks like we know that DE is congruent to GW, and DW congruent to GE, and these two triangles share that last side, EW. So we can start by stating the three sides that are congruent. So DE is congruent to WG, DW congruent to GE, and EW congruent to itself. So by side, 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 we can say that triangle DEW is congruent to angle GWE. Now that we've proved that these two triangles are congruent to one another, now we can answer the question, is angle D congruent to angle G? Well, yes, because angle D and angle G are corresponding parts of congruent triangles. So since angle D and angle G are corresponding parts of congruent triangles, we can say that angle D is congruent to angle G by CPCTC. Take a look at example 3. In the diagram below is UT congruent to ST. Well, look at the information that we have. Can we state that the triangles are congruent? We have here that VT is congruent to RT. We have SR congruent to UV, and we have angle U congruent to angle S. Which of the theorems does this correspond to? We have a side, and a non-included angle. That's not one of the shortcuts. So, are the triangles congruent? They could be, but we don't have enough information to make that case. So are the triangles congruent? Possibly, but we can't prove that they are. So, since side-side angle is not one of the theorems, we can't say for sure whether or not these triangles are congruent to each other. Okay, so step 2, if the triangles are not congruent, or if we can't prove that the triangles are congruent, then we do not have enough information to show that UT is congruent to ST. Okay, example 4. If EB is perpendicular to AC and EB bisects angle AEC, is AE congruent to EC? Okay, let's use all this information that's given to us and put it into our diagram. So we're told that EB bisects angle AEC, and anytime something bisects something, it means that it cuts it in half. That means angle AEC is cut in half. So here I can draw out that angle AEB is congruent to angle CEB. We also know that EB is perpendicular to AC, so I can draw right angles in there. So since we have two angles of one triangle congruent to two angles of the other triangle, we need to find if there's one other piece of information that we can use. In this case, these two triangles share a side, so BE is congruent to itself. So we have two angles and the included side, and so we would use angle side angle. So go ahead and list off the angles. So angle EBA is congruent to angle EBC. EB is congruent to EB, so that's the included side. And then angle AEB congruent to angle BEC. So, based on angle side angle, we can state that triangle AEB is congruent to triangle CEB. Now, since we were able to show that those two triangles are congruent to each other, now we can answer, is AE congruent to EC? Well, since AE and EC are corresponding parts of congruent triangles, we can say that AE is congruent to EC by CPC TC.